Hello there, my name is Keith Martin Salas. Today we're going to talk about paper 1 questions of physics. So let's begin. So for here, to indicate the right answer, I'm going to highlight the correct answer. Okay. So number 1, when an alpha particle collides with a nucleus of nitrogen 14, which is this over here, a nucleus X can be produced together with a proton. What is X? So we know that alpha particle is a 4-2 particle. So it collides with a 14-7. So what we do here is we add 4 to 14 because it's the one above. It's because alpha particle is 4 and 2. So we add the 4 here, which is equal to 18. Then we add the 2 here, down here at 7. So 18 and 9. So the answer here is letter C. Okay. Next question. Which of the following lists 3 fundamental forces in increasing order of strength? So here, the answer here is C. We know for a fact that among the three of these, gravity is the weakest. Then next is weak nuclear. Then it is electromagnetic. Okay, next. What is the relationship between nucleon number A, proton number Z, and neutron number N? Okay, so the formula for nucleon is proton plus neutron. So what you do here is A is equal to Z plus N. And we can see here that there is no A is equal to Z plus N. However, there is letter C, which is A minus C is equal to N. So here, what they did is that they transposed the Z. So this equation right here is still equal to A equals N plus C. So simple algebra, and the answer here is C. Okay, next, number 4. The initial number of atoms in a pure radioactive sample is N. The radioactive half-life of the sample is defined as A, time taken for one atom to undergo decay, B, probability of N over 2 atoms to undergo decay, C, time taken for N over 2 atoms to undergo decay, and D, probability that one atom will decay per unit time. So the answer here is letter C. That is because the radioactive half-life of sample is defined as time taken for N over 2 atoms to undergo decay. It is not the probability, and it is not time taken for one atom, but rather it is time taken for N over 2 atoms to undergo decay. Okay, let's now go to number 5. Some of the energy levels for a hydrogen atom are shown in the diagram. So here you can see negative 0.9, negative 1.5, negative 3.4, and negative 13.6. A table shows 4 photons with their corresponding energies. So 8.6, 10.2, 12.11, and 12.6. So the question is, an atom in its ground state, which photons could be absorbed by the atom? For number 5, the answer here is B, X and Y. Why is that so? Well, if we look over here, X and Y correspond to 10.2 and 12.1. If we add 10.2 to 13.6, then the answer would be negative 3.4, which is right over here. And for photon Y, it is 12.1. So if we add 12.1 to negative 13.6, then it would be equal to negative 1.5. As you can see, the energy levels are here, and they should be exactly equal to the numbers here. So if it is not exactly equal, then it would not be absorbed. It would not be it would not jump to the different level. My bad. So they're together. So therefore, B is the answer. Okay, let's go to number 6. Okay, for number 6, the question is that which of the following provides evidence for the existence of atomic energy levels? So the answer here is letter A. Oopsie, I didn't highlight that all. There we go. So this is because the absorption spectra is the color is the colors we see, and there is a change of colors when there is a change of atomic energy levels. That's why 6A is the answer. Okay. Okay. Number 7. A radioactive sample has activity AO at time equals 0 half-lives. So we know 1 half-life is equal to, let's say that the sample is, oh yeah, here, A sub 0. So we know for a fact that if there is 1 half-life, then A sub 0 times 1/2, that is equivalent to a sample after 1 half-life. But because the question asks for 2 half-lives, then this will be equal to A sub 0 times 1/2 times 1/2. And you can see from the choices, A sub 0 times 1/2 times 1/2 is equal to B, which is A sub 0 times 4. Let's go to number 8. Okay, for number 8, in a neutral atom, there are Ne electrons, N protons, and N neutrons. What is the mass number of the nuclei? So the answer here is B. This is a very simple question because the formula for mass number is the number of protons plus the number of neutrons. Again, the formula for mass number is the number of protons plus the number of neutrons. Okay, now we move on to number 9. So, a student suggests the following nuclear reaction between deuterium 2H and tritium, which is this one. Okay, so we have this chemical here. There we go. Okay, now the question is, where N and M are integers, what are X and Y? So here are the following choices: electron neutron, electron proton, alpha particle neutron, and alpha particle proton. So for this, we have to find out so 2 plus 3 is equal to 5. And here 1 plus 1, for X and Y, you have to find the number up here is 5 and the number down there is 2. Okay, so we go now to letter C because that is the correct answer. Okay, looks like I cannot highlight it, so what I'm going to do is I'm just going to type it down. So the answer here is letter C, and I'll just make it bold, size it other way. Okay, letter C. Okay, why is that so? Well, this is because an alpha particle is 4 above. The alpha particle is 4 and 2, while a neutron is 1 and 0. So 4 and 2 here, plus 1 and 0 here, so 4 plus 2 is equal to 5, which is 2 plus 2 is 5. Then 2 plus 0 down here is equal to 2. Remember that alpha particle is 4, 2, while a neutron is 1 and 0. Okay, so letter C is the correct answer. Okay, so let's go to the last number, number 10. Here, the nuclei of the isotope nitrogen-14 are bombarded with neutrons, and as a result, nuclei of an isotope of carbon are produced. The nuclear reaction equation for this process may be written as 14(7N). You can see it over here. Okay, so the question is, what is the nucleon number A of the isotope of carbon? Okay, we see here that we have a neutron and a proton. 1 then 0 down here, so 1 and 0 down here, while a proton is a 1 and 1. So if this neutron is 1 and 0, then this side over here is 14 plus 1, 15, plus 15, 15, then 7 plus 0 is equal to 7, so 15 and 7. Here we have a proton which is 1 and 1, so 1 plus 8, then 6 plus so we can equate the equations here. 14 plus 1 is equal to a plus 1, and a would definitely be equal to 14. That's why the answer here is C, and that is 14. Hope you learned a lot, and see you next time soon for any more tutorials. Bye.